So for limiting and excess reactants, these are your notes, and I kind of give you a run through step by step on how to do it, but I'm just going to walk you through it. Okay, so your limiting reactant is going to be basically what runs out first. Your excess is going to be what's left over. So you're going to be given two numbers in your question, so you're basically going to make two T-charts. The T-chart is what we've been using to solve our problem, so this and all the boxes. So let's go through our first example. So it says the reaction between solid white phosphorus and oxygen produces solid tetraphosphorus decoxide. So here's your chemical equation that we're going to be using, so make sure you keep that in mind. And our first problem says determine the mass of tetraphosphorus decoxide formed if 25 grams of phosphorus P4 and 50 grams of oxygen are combined. So they give you basically two givens, the 25 grams and the 50 grams. So you set up two charts, one starting with 25 and one starting with 50. For both of them, you're trying to see how much of the tetraphosphorus decoxide is made. So we go from grams of one to the grams of the other. So you set it up. You start with 25 grams of P4. You do the molar mass because you're trying to cancel out the grams. So in P4, you have 124 grams for every 1 mole. Okay. Now we have mole of the tetraphosphorus, but you're trying to get to the mole of the tetraphosphorus decoxide. So you use your chemical equation to determine how they're related. So for every 1 mole of P4, you have 1 mole of P4O10. We have gone from 1 mole of we have finally gotten to the mole of the P4O10. You're trying to get to the grams of it. So in 1 mole, you have the molar mass, which is 284 grams of P4O10. When you work this all out, you should end up with 57.3 grams of P4O10. So that is our first one. And now you do the exact same thing, but with what was given to you for oxygen. So you do the exact same thing. So 50 grams of oxygen. You figure out the molar mass to get to the mole. So remember, O2 is a diatomic element, so there's 2 atoms in it. So 32, because oxygen is 16, so times 2 is 32. Grams is going to be in every 1 mole of O2. You use your chemical equation to go from the moles of O2 to the moles of P4O10. So for every 5 moles of O2, you end up with 1 mole of tetraphosphorus decoxide. You then have to get to grams, so you use the molar mass to cancel out the the moles, and you end up with this number. You work it all out, and you end up with 88.8 grams of P4O10. The number that you have less of, so here, your smaller number is going to be your limiting reactant. So in this case, our limiting reactant is the P4. That's what we're going to run out of first. Whatever the limiting reactant makes, so the 57.3 grams, this is going to be your theoretical yield. Basically, this is what you're estimating to make, okay? So we've determined our theoretical yield, our limiting reactant. Your other one that you made more of, this is going to be your excess reactant, so what you're going to make more of, okay? So in this case, it says we worked it out. We've determined our theoretical, our limiting, and our excess, I'm sorry. Now, some questions might ask you how much excess reactant will remain after the reaction is complete. So what you do here is you start with your limiting reactant and what they gave you, so 25 grams of P4, because we're going to run out of this first. And you're trying to go from grams of P4 to grams of O2. So you're trying to figure out how much oxygen is produced if you're given this much tetraphosphorus. So you set it up as normal, your molar mass at the bottom to cancel out the grams. For every 1 mole of P4, you've got to go from P4 to O2, so you use your chemical equation still to determine the relationship. So for every 1 mole of P4, you have 5 moles of O2. You determine the molar mass because you need it in grams, and you end up with 32.3 grams of oxygen. So to determine your excess reactant, or how much is made, you're going to do what was given to you. So 50 minus 32.3 is going to give you 17.7 grams of O2 excess. Okay, so let's work out this problem together. So you have 100 grams of Na, and 100 grams of Fe2O3 are used in this reaction. Determine the limiting reactant, the reactant in excess, how much excess, and the mass of the solid iron produced. So basically your theoretical yield. So we'll start with the iron. 100 grams of iron is given to you. Sodium. Okay? And 1 mole of sodium, because that's what we're trying to get to, you're gonna have 23 grams of Na. This cancels, this cancels. Per our chemical equation, you're gonna have 6 moles of Na for every, for every, 2 moles of iron. Oh, here it asks for solid iron, so you know that's what they actually want. So for every 2 moles of iron, 1 mole of iron is going to be 56 grams. So this will cancel. Oh, that should say moles. This should say moles. Cancel. So you do 100 times 2 times 56. That number is going to be 23, or whatever number you get, you're going to divide it by 23, 6, and 1. So your answer should be 81.16 grams of Fe. Now you do it with the other substance they give you. Thank you, Dexter.
You had a pocket
in that back cabinet.
Yeah.
You have extra ones. Sorry, guys. There's still kids in here. Fe2O3, and you do the same thing. So the molar mass of Fe2O3 is going to be 160. That other one. Pull it open. Fe2O3 for every 1 mole. Okay. In our reaction, we have 1 mole of Fe2O3 for every 2 moles of Fe. Bye, have a good day. Don't you miss the bell? In 1 mole of iron, you're gonna have 56 grams. This cancels with this. This cancels with this. This cancels with this. You do your math, you end up with 100 divided by 160 times 2 times 56. You get 70 grams of iron. We have less of this, so Fe2O3 is going to be our limiting reactant. So Fe2O3, we are going to run out of that one before we run out of sodium. So that means our sodium is in excess. Okay? How much in excess? So, again, what you do, we also got our theoretical yield, which is 70 grams because that's how much our limiting reactant is going to make. So now we got to determine the excess. So our limiting reactant is 100 grams of Fe2O3. Now for our excess, you're going from your limiting to your excess. So we said our excess is going to be grams of sodium. So here's grams, so you're going to put the molar mass, which is 160 for every 1 mole. For every 1 mole of Fe2O3 you have, you're going to have 6 moles of sodium. 1 mole of sodium is going to be 23 grams. This cancels, this cancels, this cancels, this cancels, this cancels, this cancels. So then you have 100 divided by 160 times 6 times 23 is going to give you 86.25 grams of Na. Oh, no, wait, that's not the answer. 86.25 grams of Na. So this is how much is made. You're going to subtract this number for what was given to you. So in our equation, they gave us 100 grams of of Na. So you do 100 minus 86.25 you get 13.75 grams, which is your excess. So this answer belongs here.